This is week one practice assignment solution video. So let us start with question number one. Let x and y be two random variables with joint distribution given in the table where a and b are two unknown values. So in question number one, we are given a joint distribution table and there are two unknown values and they are a and b. And in the first question, we have to find marginal y is equal to 1. So before calculating the marginal, we have to calculate the value of unknown a and b. And how we will do that? We'll do that by using the axiom that sum of all the probabilities of all possible xy pair is equal to 1 for discrete joint distribution. So since summation of x belonging to domain of x, y belonging to domain of y, xy is equal to 1. So this implies that 1 by 12 plus 3 by 12 plus a plus 2 by 12 plus b plus 1 by 12 plus 3 by 12 plus 1 by 12 plus 1 by 12 is equal to 1. On simplification, we get 12 by 12 plus a plus b is equal to 1. This implies that a plus b is equal to 0. And as probabilities can't be negative, this implies that a is equal to b is equal to 0. So now we'll calculate the marginal. So for calculating the marginal, so for example, if we have to find marginal y is equal to some small y, then what we do, we sum the probabilities of all xy pair where y is equal to small y and x takes different values. So this will be equal to summation x belonging to domain of x is xy xy. Okay. So now we'll use this in our question. So we have to calculate marginal y is equal to 1. So for calculating marginal y is equal to 1, we'll sum all the possible probabilities of xy pair where y is equal to 1 and x takes different values. So this will be equal to probability x is equal to 0, y is equal to 1 plus probability x is equal to 1, y is equal to 1 plus probability x is equal to 2, y is equal to 1. So from the table, these we can simply put these values. So that is from the table, we are simply adding the probabilities of this row. So this is 2 by 12 plus b plus 1 by 12. So this is as a is equal to b is equal to 0. So this will be 3 by 12. And this is our required answer for question number 1. Now coming on question number 2. Question number 2 is based on the same table. And in question number 2, we have to find the probability that y is equal to 1 given x is equal to 2. So basically in question number 2, we have to find conditional probability. So we'll use the formula for conditional, that is conditional is equal to joined by marginal here. So here a probability that y is equal to 1 given x is equal to 2. This will be equal to probability, the joint probability that x is equal to 2, y is equal to 1 divided by marginal x is equal to 2. So now let us make this equation number 1 and let us separately calculate marginal x is equal to 2. So for calculating the marginal, we'll again use the same formula, that is, for example, uh, if we have to find the marginal that uh, x is equal to some small x, this will be equal to sum of probabilities of all possible xy pair where x is equal to the small is equal to small x and y takes different value. So this will be equal to summation y belonging to domain of y fxy. Okay. So for calculating marginal x is equal to 2, this will be equal to uh, prob this will be equal to sum of probabilities of all possible xy pair where x is equal to 2 and y takes different value. So basically from the table, we'll add probabilities of this column right here. So this will be equal to probability x is equal to 2, y is equal to 0, plus probability x is equal to 2, y is equal to 0, plus probability x is equal to. So marginal x is equal to 2 will be equal to sum of probabilities of all possible xy pair where x is equal to 2 and y takes different values. So this will be equal to probability x is equal to 2 and y is equal to 0, plus probability x is equal to 2 and y is equal to 1, plus probability x is equal to 2 and y is equal to 2. So from the table we will put these values and find the marginal x is equal to 2. So this is a plus 1 by 12 plus 1 by 12. And as a is equal to 0, this will be equal to 2 by 12. So now what we'll do, we'll simply put the value of marginal x is equal to 2 in equation number 1. So now we will simply calculate the conditional by simply putting the values. So this will be conditional y is equal to 1 given x is equal to 2. This will be equal to a joint probability that x is equal to 2, y is equal to 1 divided by marginal x is equal to 2. So from the table, what is a joint probability that x is equal to 2 and y is equal to 1? So x is equal to 2 and y is equal to 1. This is 1 by 12. So now simply putting the values. So this is 1 by 12 and marginal x is equal to 2 we have just calculated. It is 2 by 12. So the answer comes out to be 1 by 2. This is the required answer. Now coming on question number 3. Question number 3 is also on the same table. And in question number 3, we have to find the probability that x is equal to 0 and y is greater than equal to 1. So for question number 3, we just have to think of uh, all possible xy pair for this condition, that is x is equal to 0 and y is greater than equal to 1. So there are only two pairs uh, which will satisfy this condition, and so the probability that x is equal to 0 and y is greater than equal to 1, this will be equal to probability x is equal to 0, y is equal to 1 plus probability x is equal to 0 and y is equal to 2. So from the table, we'll simply put the values. The values are this 2 by 12 and 3 by 12. So this is equal to 2 by 12 plus 3 by 12 the answer is 5 by 12. Moving on, question number 4. Question number 4 says that let x be a random variable which is uniformly distributed in discrete values 1, 2, 3, 4, 5, and 6, and let y be number of times 2 occurs in x throws of a fair die, and we have to choose the incorrect options among the following. So the setting of question is that x is a random variable which is uniformly distributed, and on the basis of value random variable x is taking, we are flipping a fair die x number of times, and y is another random variable which is the number of times 2 occurs in x throws of a fair die. So in the options, we are given conditional probability of y given x. So before going through the options, let us look at the distribution of conditional probability of y given x. So for y is equal to some small y, probability that y is equal to some small y given x is equal to some small x, this will follow binomial distribution where n is equal to x and p is equal to 1 by 6. And why is that? Because what is x here? X is the number of times we are throwing the fair die, and y is the number of times we got 2. So we can look at it as number of x as number of trials and y as number of success we want. So this will follow binomial distribution. So now let us go through options one by one. So for option number 1, we have to find the probability that x is y is equal to 2 given x is equal to 2, and this will also follow binomial 2 comma 1 by 6. So now calculating the value. So probability y is equal to 2 given x is equal to 2. This will be equal to 2c2 1 by 6 raised to the power 2, and this will be equal to 1 by 36. And as the value in the first option is different, that is in the first option it is given that probability y is equal to 2 given x is equal to 2 is 1 by 6, and as we have to mark the incorrect option, so this is the correct option. Now checking option number B. So in option B, we have to find probability y is equal to 2 given x is equal to 4. So this will also follow binomial 4 comma 1 by 6. And now calculating the value. So probability y is equal to 2 given x is equal to 4. This will be equal to 4c2 1 by 6 raised to the power 2, 5 by 6 raised to the power 2. And on calculating, this will be equal to 5 raised to the power 2 divided by 6 raised to the power 3. And as in the option, the conditional probability y is equal to 2 given x is equal to 4 is 5 raised to the power 2 divided by 6 raised to the power 3 is given, which is the correct probability. So we won't mark this option. Now checking option number C. So option C, in option C, we have to find conditional probability y is equal to 5 given x is equal to 6. This will be also following binomial 6 comma 1 by 6. So now calculating the probability. So probability y is equal to 5 given x is equal to 6 will be equal to 6c5 1 by 6 raised to the power 5 into 5 by 6. Non Further calculation, this will be equal to 5 divided by 6 raised to the power 5. As in the option C, same value is given, so we'll not mark this option. Now checking option number D. So in option D, we have to find the probability that y is equal to 6 given x is equal to 5. As we are throwing the die 5 times, we can't get 2 6 times. Okay, so the probability will be 0. As in the option number D, different value is given, so option number D is correct. So the correct answer is A and D. Now coming on question number 5. Question number 5 says that let the random variables x and y each has range 1 to 3 and given below is the joint PMF of x and y. And clearly we can see in the joint PMF of x and y, C is the unknown value here. And we have to find the joint probability that x is greater than equal to 1 and less than equal to 3 and y is greater than 1 and less than equal to 3. So before calculating the probability, we have to find the value of unknown C here. And how we will do that? We will do that by using the axiom that sum of probabilities of all possible xy pair is equal to 1 for discrete joint distribution. So uh, sum, this will be summation x belonging to domain of x, y belonging to domain of y, fxy is equal to 1. Now, what we'll do, we'll find all possible xy pair. And so these are all possible xy pair and we'll simply find the values of probability by putting value of x and y in the given PMF and the probabilities will come out in terms of C. So these are the probabilities and on further simplification, we get value of C is equal to 54. Now finding the required probability, that is probability of x being greater than equal to 1 and less than equal to 3 and y being greater than 1 and less than equal to 3. So now again we have to sum all possible xy pair probability which will satisfy this condition, and the pairs which will satisfy these conditions are probability x is equal to 1, y is equal to 2 plus probability x is equal to 1, y is equal to 3 plus probability x is equal to 2, y is equal to 2 plus probability x is equal to 2, y is equal to 3 plus probability x is equal to 3, y is equal to 2 plus probability x is equal to 3, y is equal to 3. And this will be, so this will be equal to what? We'll simply find the values of probability by putting xy in PMF. So we'll get, and let us take out 1 by c common from all the terms. So we'll get 1 by c 5 plus 7 plus 6 plus 8 plus 7 plus 9. Okay, so and this will be equal to 42 and put the value of c which is 54. So the required answer is 7 by 9. Now coming on question number 6. Question number 6 is that the joint PMF of random variables x and y are given in the table and z is another random variable which is equal to x square y. And we have to find the range of z given y is equal to 2. So for finding the range of z given y is equal to 2, so first of all, what will be the value of z when y is equal to 2? So when y is equal to 2, z is equal to 2 times x square. And what are the values x can take? X can take value 1, 2, 3. So the values z can take are 2, 8, and 18. But as the joint probability that x is equal to 2 and y is equal to 2 is 0, that is given in the table. So the probability of z being 8 is equal to 0. So the values z will take are 2 and 18. And this is the required answer. Now coming on question number 7. In question number 7, we have to find the probability that z is equal to 18 given y is equal to 2. So basically in question number 7, we have to find the conditional probability. So for calculating the conditional probability that z is equal to 18 given y is equal to 2, we'll simply use the formula that conditional is equal to joint by marginal. So this will be equal to joint z is equal to 80, y is equal to 2 divided by marginal y is equal to 2. And when y is equal to 2, z will only be 18 when x is equal to 2. So the joint probability that z is equal to 18, y is equal to 2, this will be equal to joint probability that x is equal to 3, y is equal to 2 divided by marginal y is equal to 2. And now for calculating the marginal, what we'll do, we'll sum all the probabilities of this row. This means that we'll sum probabilities of all possible xy pair where x takes different values and y is equal to 0. From the table, joint probability that x is equal to 3, y is equal to 2, this will be equal to 4k, and the marginal will be equal to 2k plus 0 plus 4k. So this will be equal to 4k by 6k. So the answer is 2 by 3. Now coming on question number 8. Question number 8 says that from a sack of fruits containing 3 mangoes, 2 kiwis and 3 guavas, a random sample of 4 pieces of fruit is selected. If x is the number of mangoes, y is the number of kiwis in the sample, then find the joint probability distribution of x and y. And we are given 4 options for joint distribution table of x and y. So what should be the approach? We should calculate the joint probability of x and y pair, uh, for which probabilities in different table is different. For example, uh, the joint probability that x is equal to 2, y is equal to 1 is different in table A and B. So let us calculate this joint probability. And as the experiment of drawing 4 pieces of fruit from sack of fruits containing 3 mangoes, 2 kiwis and 3 guavas follows hypergeometric distribution. So the probability will be 3C2, 2C1, 3C1 divided by 8C4, and the value comes out to be 18 by 70. And in the table A, different value is given. So let us eliminate table A. Now we have to calculate probability of XY pair for which table B and table C have different values. So one such pair is x is equal to 0, y is equal to 2. So probability that x is equal to 0, y is equal to 2. This is equal to 2C2 into 3C2 divided by 8C4. And this is equal to 3 by 70. As a different value is given in table C, uh, so we will eliminate table C. Now it comes to table B and table D. So we have to find the probability of XY pair, which has different values in table B and table D. And one such value is probability x is equal to 2, y is equal to 0. And this probability will be 3C2 into 3C2 divided by 8C4, and the value comes out to be 9 by 70. As different value is given in table D, so the correct table is table B. So this is the right answer. Now coming on question number 9. Question number 9 says that suppose you flip a fair coin. If the coin lands heads, you roll a fair six-sided die 50 times. If the coin lands tails, you roll the die 51 times. Let x be 1 if the coin lands heads and 0 if the coin lands tails. Let y be total number of times you get the number 5 by throwing the die. Find the probability that x is equal to 1 given y is equal to 10. So basically the setting of the question is that we have a fair coin. On flipping the fair coin, if we get heads, we'll throw a fair die 50 times, and if we get a tails, we will throw fair die 51 times. And y is the random variable associated with total number of times we get number 5 on throwing the die. So now for calculating the probability that x is equal to 1 given y is equal to 10. So we'll simply use the formula that marginal is equal to joined by marginal. So this will be joint probability that x is equal to 1 given y is equal to 10 divided by the marginal, that is prob probability y is equal to 10. Now we can rewrite joint as product of conditional and marginal. So this joint can be rewritten as probability y is equal to 10 given x is equal to 1 into marginal x is equal to 1. So now divided by the marginal y is equal to 10, and also the marginal y is equal to 10 will be equal to the joint probability that x is equal to 1, y is equal to 10 plus probability x is equal to 0, y is equal to 10. And why is that? Because y is equal to 10 can be achieved through two ways. That is, first, if x is equal to 1, which means we got heads. Another is x is equal to 0, which means we got tails. So now what we'll do, we'll again write joint as product of conditional and marginal for the denominator as well. So it will be equal to probability x is equal to 1 into conditional probability that y is equal to 10 given x is equal to 1 plus probability x is equal to 0 into conditional probability that y is equal to 10 given x is equal to 0. Now writing the numerator, so this will be y is equal to 10 given x is equal to. Now so what we will get, we get probability y is equal to 10 given x is equal to 1 divided by conditional probability y is equal to 10 given x is equal to 1 plus probability y is equal to 10 given x is equal to 0. So now let us look at the distribution of y given x. So the distribution of y given x is equal to 0 will be binomial 51, where n is equal to 51 and p is equal to 1 by 6. And why is that? Because x is equal to 0 here represents that we are throwing the die 51 times, and y is the number of a success, that is y is the number of times we got 5. So the probability of getting a 5 for a fair die is 1 by 6. So that's why p is equal to 1 by 6 and n is equal to 51 for this binomial distribution. Similarly, y given x is equal to 1 will follow binomial 50 comma 1 by 6. for the same reason. So now simply using the distribution, so we get, so conditional probability y is equal to 10 given x is equal to 1 will be 50 C10 1 by 6 raised to the power 10, 5 by 6 raised to the power 40 divided by 50 C10 1 by 6 raised to the power 10, 5 by 6 raised to the power 40 plus 51 C10 1 by 6 raised to the power 10, 5 by 6 raised to the power 41. On further simplification, we get 50C10 divided by 50C10 plus 51C10 into 5 by 6. And on further simplification, we get the required answer, which is 82 by 167. Now coming on question number 10. Question number 10 says that three balls are selected at random from a box containing 5 red, 4 blue, 3 yellow and 6 green colored balls. If X, Y and Z are the number of red balls, blue balls, green balls respectively, choose the correct options among the following. So here we are given the options. So let us go through the options one by one. So for option A, we have to find the joint probability that X is equal to 1, Y is equal to 0, and Z is equal to 2. And as the experiment of drawing three balls at random from the container follows hypergeometric distribution, so this joint probability will be equal to 5C1 for selecting one red ball out of 5 red balls, 6C2 for selecting 2 green balls out of 6 green balls, divided by 18C3 for selecting 18 balls, for selecting 3 balls out of the 18 balls. So this is equal to, on simplification, we get 25 by 272. So option A is correct. Now checking option B. In option B, we have to find the joint probability that x is equal to 1, y is equal to 1, and z is equal to 1. So here, this will be equal to 5C1 for selecting one red ball, 4C1 for selecting one blue ball out of 4 balls, and 6C1 for selecting one green ball, divided by 18C3 for selecting 3 balls out of all 18 balls. So this will be equal to, on simplification, we get 5 by 34. So option B is also correct. Now checking option C. So in option C, we have to find the joint probability that x is equal to 1, y is equal to 0, given z is equal to 2. So, so it is already given that z is equal to 2. So we simply have to pick one red ball and 0 blue ball. So this will be equal to 5C1 divided by 16C1. This is equal to 5 by 16. So option C is incorrect. Now checking option D. So in option D, we have to find the joint probability that x is equal to 0, y is equal to 0, and z is equal to 3. This will be equal to 6C3 divided by 18C3, as we are selecting 3 green balls. And on simplification, we get 5 by 204. So option D is also correct. Now coming on question number 11. Question number 11 says that a computer system receives messages over three communication lines. Let xi be the number of messages received on line I in 1 hour. Suppose that the joint PMF of x1, x2, and x3 is given below. So this is the joint PMF of x1, x2, and x3. Now for finding the joint PMF of x1 and x2, what we'll do, we'll sum the probabilities of all x1, x2, and x3 pair where x1 and x2 are constant and x3 takes different values. So this will be equal to summation x3 is 0 to infinity. So now simply putting the PMF formula given to us. So this will be equal to summation x3 from 0 to infinity 1 minus p1, 1 minus p2, 1 minus p3, p1 raised to the power x1, p2 raised to the power x2, p3 raised to the power x3. So now taking out the constant terms. So as x3 is varying, all these terms are constant. So this will be equal to 1 minus p1, 1 minus p2, 1 minus p3, p1 raised to the power x1, p2 raised to the power x2, summation x3 from 0 to infinity, p3 raised to the power x3. And for the simplification, we get 1 minus p1, 1 minus p2, 1 minus p3, p1 raised to the power x1, p2 raised to the power x2. Now, this is infinity GP series, so this will be 1 plus p3 raised to the power 2 plus p3 raised to the power 3 and so on. So now using the GP formula, so on simplification we'll get 1 minus p1, 1 minus p2, 1 minus p3, p1 raised to the power x1, p2 raised to the power x2, and on using the infinity GP formula we get 1 by 1 minus p3. With further simplification, we will cancel out these two terms and we'll get 1 minus p1, 1 minus p2, 1 raised to the power x1, p2 raised to the power x2. And this is the required answer. So option C is correct. Now coming on question number 12. In question number 12, we have to find the marginal of x2. And in the previous question, we computed the joint PMF of x1 and x2. So we'll use this PMF to find the marginal of x2. And how we will do that? We'll find the marginal of x2 by summing the probabilities of all x1 x2 pair where x2 is fixed and x1 takes different values. So this will be equal to summation x2 from 0 to infinity fx1 so this will be equal to now simply uh, putting the PMF we will get summation x2 is equal to 0 to infinity 1 minus p1 1 minus p2 P1 raised to the power x1, P2 raised to the power x2. Now for the simplification, we will take out constant terms. So it will be 1 minus P1, 1 minus P2, P1 raised to the power x1, summation x2 from 0 to infinity, P2 raised to the power x2. On further simplification, we get 1 minus P1, 1 minus P2, P1 raised to the power x1. And as this is an infinity GP series, so we will write it as 1 plus P2 raised to the power 1 plus P2 raised to the power 2 plus so on. So now we'll use the formula for infinite sum of infinity GP series. So in further simplification, we'll get 1 minus P1, 1 minus P2, P1 raised to the power x1, and on applying the formula, we'll get 1 by 1 minus P2. So now these two terms will get cancelled, and the marginal of x2 will be 1 minus P1 into P1 raised to the power x1. And this is the required answer. So option number D is correct. Now coming on question number 13. In question number 13, we have to find the joint probability that x1 is equal to 2 and x3 is equal to 5. So before that, we have to find the joint PMF of x1 and x3. And for that, what we'll do, we'll sum the probabilities of all x1, x2, x3 pairs where x1 and x3 are constants and x2 is taking value from 0 to infinity. So on simplification, so first of all, simply put the PMF, joint PMF of x1, x2, x3 given to us. So this will become summation x2 is equal to 0 to infinity 1 minus P1, 1 minus P2, 1 minus P3, P1 is to the power x1, P2 raised to the power x2, P2 raised to the power x3. So on further simplification, what we'll do, we'll take the constant terms out of the summation. So this will become 1 minus P1, 1 minus P2, 1 minus P3, P1 raised to the power x1, P3 raised to the power x3, summation x2 from 0 to infinity, P2 raised to the power x2. So this is infinity GP series. So on further simplification, we will get 1 minus P1, 1 minus P2, 1 minus P3, P1 raised to the power x1, P3 raised to the power x3, and this is infinity GP series. So this will be 1 plus P2 raised to the power 1 plus P2 raised to the power 3 plus so on. So now we'll use the formula for sum of infinity GP. So on further simplification, we will get 1 minus P1, 1 minus P2, 1 minus P3, x P1 raised to the power x1, P3 raised to the power x3, and by using the formula, this will become 1 by 1 minus P2. On further simplification, these two terms will get cancelled out. So the joint PMF of x1 and x3 will be 1 minus P1, 1 minus P3, P1 raised to the power x1, P3 raised to the power x3. So this is the required PMF. And now simply substituting the values, we'll find the probability that x1 is equal to 2 and x3 is equal to 5. So simply put the value of x1 is equal to 2 and x3 is equal to 5 in the PMF. So we'll get 1 minus P1, 1 minus P3, P1 raised to the power 2, P2 raised to the power 5. And this is the required answer. Now coming on question number 14. Question number 14 says that a coin is tossed twice. Let X denotes the number of heads on the first toss and Y denotes the total number of heads on two tosses. If the coin is biased and a head has 40% chance of occurrence, find the probability that Y is equal to 2. So for question number 14, we have to find the probability that Y is equal to 2. This means that we have to find the probability that on the first toss we got a heads and on the second toss as well we got heads. So this will be equal to joint probability that X is equal to 1 and Y is equal to 2. So the probability of getting two heads on throwing the dice two times will be 0.4 into 0.4, which is 0.16, and this is the required answer for question number 14. Now coming on question number 15. In question number 15 we have to find the probability that X is equal to 1. So probability that X is equal to 1 is probability of getting heads on the first toss, so this will be equal to 0.4. Now coming on question number 16. In question number 16 we have to find the probability that X is equal to 1 and Y is equal to 1. This means that we have to find the probability that on the first toss we got a heads and on the second toss we got a tails. So this will be equal to 0.4 into 0.6, and this is equal to 0.24, and this is the required answer for. Now coming on question number 17. Question number 17 says that let x1, x2 and x3 be three random variables with defined joint PMF where xi belongs to -1, 1 for each I. If the joint that x1 is equal to -1, x2 is equal to -1 and x3 is equal to 1 is equal to 1 by 8, and marginal x2 is equal to 1 is equal to 1 by 6, and conditional x3 is equal to 1 given x2 is equal to -1 is 1 by 5, then we have to find the conditional that x1 is equal to -1 given x2 is equal to -1 and x3 is equal to 1. For finding the required conditional probability, that is fx1 is equal to -1 given x2 is equal to -1 and x3 is equal to 1. So we'll simply use the formula that conditional is equal to joined by marginal. So this will be equal to joint probability that x1 is equal to -1, x2 is equal to -2 and x3 is equal to 1 divided by joint x2 is equal to -1 and x3 is equal to 1. And now this will be equal to, and as joint can be written as product of conditional and marginal, so this denominator will be conditional that x3 is equal to 1 given x2 is equal to -1 into marginal fx2 is equal to -1. And now, as we in the question we are given the marginal that x2 is equal to 1, so what we'll do, we'll write in place of marginal x2 is equal to -1, we'll write 1 minus marginal x2 is equal to 1, and now simply substituting the given values, so this will be equal to 1 by 8 divided by 1 by 5 into 1 minus 1 by 6, so the value comes out to be 6 by 8 and it is 0.75. This is the required answer for question number 17. Now coming on question number 18. Question number 18 says that suppose that the number of people who visit a yoga academy each day is a Poisson random variable with mean 30. Suppose further that each person who visit is independently a girl with probability 0.5 or a boy with probability 0.5. Find the joint probability that exactly 10 boys and 15 girls visit the yoga academy on a given day. So let uh, X denotes the number of boys who visit yoga academy on a particular day. Y denote the number of girls who visit Yuka Academy on a particular day, and let Z be the total number of people who visit Yuka Academy on a particular day. So we have to find the joint probability that x is equal to 10 and y is equal to 15. So we can write joint as product of conditional and marginal. So this will be equal to probability x is equal to 10, y is equal to 15, given z is equal to 25 into marginal probability z is equal to 25. So as z follows Poisson distribution with mean 30, so on simplification we'll get probability x is equal to 10 and y is equal to 15, given z is equal to 25 into e raised to the power minus 30, 30 raised to the power 25 divided by 25 factorial. Now let us separately look at the joint distribution of x is equal to 10, y is equal to 15, given z is equal to 25. So this will follow a binomial distribution where n is equal to 25 and p is equal to 0.5. And why is that? So on considering a boy visiting Yuka Academy success, uh, so here Z is the total number of people visiting the Yuka Academy, and 10 is the number of boys visiting the Yuka Academy, which is success for us. And what is the probability that a boy visits Yuka Academy? It is 0.5. So this will follow a binomial. So from this probability that x is equal to 10 and y is equal to 15, given z is equal to 25, this will be equal to 25 C10, 0.5 raised to the power 10, 0.5 raised to the power 15. So this is for number of 10 boys visiting the Yoga Academy, and this is for 15 girls visiting the Yoga Academy. So on further simplification, we get 25 factorial by 10 factorial into 15 factorial into 0.5 raised to the power 25. Now simply putting this value, let us make this equation number 2, and let us make this equation number 2. On using equation 2 in 1, what we get? So the joint probability that x is equal to 10 and y is equal to 15 is equal to 25 factorial by 10 factorial into 15 factorial into 0.5 raised to the power 25 into e raised to the power minus 30, 30 raised to the power 25 divided by 25 factorial. And for the simplification, these two terms will get cancelled out, and on so this value will be e raised to the power minus 30, 15 raised to the power 25 divided by 15 factorial into 10 factorial. And so this is the required answer.